Yesterday we looked at using graphing to solve a system of equations, of linear equations. And so today we'll look back at that, but we're also going to look at using a method called substitution to solve a system. The warm-up is practice solving for variable. Solve this equation for w. And what that means is get w by itself. Let's practice that. So again, we have y minus w equals 7. Let's get rid of the y here, subtract y from each side. So you'll have negative w equals 7 minus y. And this is a negative 1 times a w, so you can divide each term by a negative 1 to get rid of it. On the left-hand side, and you get w equals negative 7 plus y. Or you could write y minus 7. And the reason why we do that is we're going to look at this method today called substitution, where you want to get one letter by itself, and it might have other letters in the equation. So in today's lesson, we're going to look at this one situation. Using substitution to solve a system of equations. No, okay. Mira and her younger brother Isaac are running a race. Because Isaac is faster, he gives Mira a 50-foot head start. Mira runs at 12.5 feet per second, and Isaac runs at 14.3 feet per second. How far will they be from the starting line before Isaac passes Mira? If Mira wants to win the race, how long should the race be? And recall that distance is rate times time. So, first step, what is the independent variable? And there's two variables here, time and distance. So independent would be time. And the reason why is the distance depends on the time. So again, distance depends on the time. And so the dependent variable is distance, making the independent variable time. Let's write a system of equations for Isaac and Mira in slope-intercept form. So we need the starting value and the rate of change. All right, so let's do Isaac first. We have y equals, and he starts right at the starting line, and he runs 14.3 feet per second. Mira, however, gets a head start, so let's the y-intercept the starting, and she gets a 50-foot head start, and her rate is 15.5, or 12.5 feet per second. So her slope, or rate of change, is 12.5x. So yesterday we knew that we could graph those, and we could figure out a point of intersection, and we'll actually use that to check. I should pop up my graphing calculator. But today, let's go here. How could we solve this problem? We could use the graphing calculator. But also think about this. If A equals B and B equals C, what other conjecture can you make? And remember Isaac was y equals 14.3x. And remember Mira was y equals 50 plus 12.5x, I believe. Let's double check. Okay, so recall these two equations, and related to this, if A equals B and B equals C, what other conjecture can you make? Well, they both equal B, so A must equal C. A equals B, B equals C, A and C must also be equal. So we can use that to solve the system right here. If y equals this and y equals this, we want to find where they're tied or where they equal each other. So we can set them equal and solve. And this is called substitution. So it says use substitution to solve the system for Isaac and Mira. Well, we want to know when they're tied. When does 14.3x? When does that equal 50 plus 12.5x? All right, we'll solve the equation. Let's get rid of this 12.5x from each side. We have 50 equals, and for my calculator, 14.3 minus 12.5, 1.8x. Get rid of the 1.8 by dividing. So 50 divided by 1.8. Okay, and let's see if I wrote these equations right. Okay, so 50 divided by 1.8 is 27.7 repeating, so that's how long the race would have to be. So that's x, and remember x, the independent variable, this is time. So if you want the distance, so we want to know that as well, we're going to plug that in to one of the equations. So y equals 14.3 times 27.7 repeating. So I'll multiply by 14.3, and it's about 397.2 repeating. So this is the distance. So at 397.2 meters and at 27.7 seconds, they are tied. Oops, push this down. So in terms of the problem, again, it means at 27.7 seconds at a distance of, what was it, 397.2 meters. They are tied. So if Mira wants to win the race, she would make the race shorter, because that's when Isaac finally catches up to her. All right, we can do that on the graphing calculator. This is what we did yesterday. So from yesterday, we can open a new document, add a graph. We can enter in Isaac 14.3x. Hit enter. There's his. We can hit tab, and we can enter in Mira's at 12.5x, but she started 50 meters ahead. And this window is too small to see it. So what we did yesterday is we did that zoom fit to kind of get a good, some menu window zoom fit. And you can see, all right, oh, it's taking a while to meet. Here's their point of intersection right here. To calculate it, we can go to Menu, Analyze Graph, Intersection, and go to the left and right of that. And there's that intersection point, and they round it to 27.8, 397 meters. So calculator works, substitution works. Let's practice some more substitution. We did this one on the calculator yesterday, but let's do it by substitution. All right, so first step for substitution, solve one equation for x or y. Substitute the first expression into the second, solve, and then you're going to substitute back in, solve for y. So again, for the phone plan, here's our system of equations. To lease it was y equals 25 plus 56, so it was $81 a month. For T-Mobile, it was y equals 749 plus 30x. So substitution, if one variable is solved for, so if one letter is by itself, you plug that in into the second equation. So here we have 81x equals 749 plus 30x. Let's subtract 30, I forgot the x, minus 30x from each side. So 81 minus 30 is 51x equals 749. Divide that by 51. It was at, we rounded, but about 14.7 months. And if I keep that number in my calculator, I can calculate the actual cost. So at this time, the two phone plans were tied. You've paid the same amount, and to get that amount, you plug into y. Y equals, you can use either equation. I'll use the top one. 81 times our 14.7. And I have my last answer in my calculator, so it's going to be a little bit more accurate, but I'm going to multiply my last answer times 81, and I'll get 1189.59. So what this means is that 14.7 months, I've paid the same amount in each plan. And then at that time, T-Mobile, which was more expensive because of the upfront cost of the phone, becomes cheaper. Okay, so there's how you can solve by substitution. Let's do another one. This one looks different because we only have one y by itself. But when you do that, you can use substitution to plug this in for this y. So you're going to totally substitute or replace the y with this right here. So I have negative 5x minus 5, and instead of y, it's like a substitute teacher. A teacher totally replaces me. We're going to totally replace the y with the 15 plus the 8x. And that's going to equal negative 30. So there's the first step in this process. We can go back here. So solve one equation for x or y. That was done. Substitute the first expression in the second equation. Now let's solve for the variable. Okay, so we're going to distribute here. Negative 5x minus 5 times 15, which is 75. And then negative 5 times 8x is negative 40x equals negative 30. Combine like terms. Negative 45x minus 75 equals negative 30. Get rid of the minus 75 by adding it to each side. Negative 45x equals, this is 45, I better double check, 75 minus 30, that's 45. Divide each side by negative 45. So x equals, I should get rid of that. X equals negative 1. But we're not done. We're trying to find the point of intersection. Where do these two meet? And we only have the x value. So now we have to solve for y, and you can use either equation. I'm just going to use the top equation because y is already by itself. So I'm going to use this equation. And we have y equals 15 plus 8 times negative 1. Y equals 15. 8 times negative 1 is negative 8. So y equals 7. So these two lines would cross at negative 1, 7. We can write that as an ordered pair. If we were to graph them, here's where they cross. Now the problem with graphing, you could graph the first one pretty easily, but if you wanted to graph the second one, you would have to get y by itself so that you could type it into the graphing calculator. So we use substitution when one letter is by itself, and you can substitute in pretty easily.